Welcome to day number 4 of Learn Shapr3D in 10 Days for Beginners. I'm Kevin Kennedy, and today we'll design a 3D printable phone case from existing CAD data. We'll look at importing third-party files, projecting geometry, cutting with Extrude, and the Sweep command. Let's get started with a new design. To import CAD data, head to the File menu, Import. You can also use Shift plus Command plus I. You'll generally want to use a step file when a native Shapr3D file is not available. The step format is a widely used data exchange format accepted by many CAD programs. You can follow along using the Pixel 3 file that I've linked in the video description or by finding a download of your phone on grabcad.com. I'll also link to some other recommended sites to find existing CAD data. After selecting Open, you'll find that the step file is imported and now appears in our design. Notice that imported data is automatically placed within a folder in the Items Manager. This file is also sitting in the wrong orientation, as I'd like it to lay flat on the bottom plane. We can select the folder in the Items Manager and use the rotation slider to rotate this 90 degrees. This is not necessarily required, but I prefer to design objects as they sit in real life. This also makes it the desired orientation for 3D printing. To create our foam case, we'll want to use the Sweep command, as Sweep lets us define a shape that follows a specified path. That means we can create a sketch profile that wraps around the outer side of the phone. We can then reference the phone file as the sweep's path. Let's start by looking at the front view of the orientation cube so we can sketch out the profile. Instead of sketching geometry from scratch, we can project existing edge lines using the Project tool. This is true when you have any 3D bodies in your design. It does not need to be imported geometry. I'll type Project and notice we can project edges and sketches. Select the Project Sketches tool. You can then zoom in and carefully select the edges, making sure not to select the entire face. You'll see blue highlights when the edges are selected. With my file, I'll need to do this a total of 5 times as the existing faces of the 3D body break up the sketches. We also need to double check the tool is set to the Sketches option. This ensures we create a new sketch instead of imprinting the edges on our existing body. You can toggle this anytime before completing the tool. Select the planar face to project the sketches onto, then select the blue check mark when done. I'll also hide the foam body in the Items Manager so we can see the sketch. The Sweep command requires a fully closed sketch profile, so we'll need to connect any open endpoints by clicking and dragging them to one another. Be careful doing this. You may need to lock any geometry that you don't want to move. Otherwise, use the reference and snapping points to ensure the geometry doesn't change. Notice we can reference the diameter of the circle. This curvature is important and we don't want it to change, so we'll shift-click everything followed by the lock constraint. Remember, locking our geometry prevents it from changing unless we first unlock it. You can now use the line tool to create the rest of the closed profile. Starting at the top, I'll head 1 mm up, followed by the return key. At times, you may only know or want to define some dimensions. You'll find it sometimes more efficient to sketch out all the lines first, followed by dimensioning and constraining them. For example, I'll create a few additional lines without defining their dimensions. After sketching, always start by adding constraints. This will ensure things don't move as you apply dimensions. Clear out any active tool with the Escape key. Let's make sure all of the lines have a vertical horizontal constraint applied. This will ensure they remain in the correct orientation. I like to first dimension the bottom vertical line, setting this to 1.5 mm. At this point, I'm not worried about this bottom area aligning with the top, as we're going to fill the entire bottom of the phone case. Lastly, I'll shift-click the curve and straight line to define the distance between them, making this 1.5 mm as well. Turn your phone 3D body back on and double-check that the geometry still matches. Later on, we'll factor in a small clearance. You can also change your view to double-check that you have a blue background highlight representing a fully closed sketch profile. Activate the sweep command from the Tools menu and select the closed profile. We then have to select Next, which allows us to define the path that the profile follows. We can simply select the top edge all the way around the foam model. Once complete, select Done. Let's also select our body and apply a color so it's easier to distinguish the case from the phone. The color you choose is a personal preference. I also like to add a white color to imported geometry, which makes it easier to reference the geometry edge lines. We can now round over the sharp edges of our case by using the Fillet tool. If you recall from day number 1, we can simply shift-click and select both the top and bottom edge. Then drag the arrow out to create a fillet or in to create a chamfer. I'll create a 3mm fillet. I'd like to move the top inner edge a 0.5 mm back. You can quickly offset faces by selecting them and dragging the arrow. In Shapr3D, you don't have to select every single face if the faces have tangent continuity. In short, when the adjacent faces have smooth transitions. In this case, selecting one face in each of the 4 sections will allow us to move the entire surface. Define the dimension as -0.5 mm followed by the return key. We can also apply a small 0.5 mm chamfer on the top edge. In this case, the chamfer tool will automatically apply it to all adjacent edges. I would now like to close off the bottom of the phone case. We also need to consider adding holes for the camera and fingerprint sensor. Looking directly at the bottom, I'll use the Project Sketch tool to project the existing edges into a new sketch. Select the edges all the way around the phone case and select any camera or sensors your model has. After defining the objects to project, we'll need to select the planar face for the sketch. In this case, we can project it right onto the planar face of the phone. After selecting Done, hide the phone body in the Items Manager. Looking from a perspective will help you once again double check that your sketches are fully closed profiles, which is required to use with the Extrude command. However, before extruding, make sure to offset the geometry to allow sufficient clearance around the camera and fingerprint sensor. Simply select the geometry, select Offset Edge, and define the offset distance. I'll set this as 1 mm. Most phones also have sensors and flash next to the camera. Take a minute or two to sketch out some additional geometry next to the camera hole. Once finished, we can select the close profile and extrude this up to our distance of 1.5 mm. Notice the color is not carried over. This is because our foam backing is a separate 3D body in the Items Manager. Consider adding fillets or chamfers to any hole cutouts that you create. If you plan to 3D print this, I also recommend adding a clearance of 0.5 mm. This, along with TPU filament, will provide enough flex in the final print to serve as a functional phone case. Select the 2 interfaces and type out -0.25 mm. This will offset the faces on each side, totaling our desired clearance of 0.5 mm. Keep in mind the bottom face is a separate 3D body, so you'll want to offset that 0.25 mm as well. Lastly, we'll want to create cutouts for the charging ports and buttons. I'll look at the front view to create a cutout for the charging port. Remember, we can hover over the planar face, followed by the space bar. This will reorient the view to look straight at it. We can project the existing geometry to a sketch just as we did with the sweep profile and camera cutouts. Once you've projected the geometry, you'll want to select the closed profiles that you would like to cut out. We'll want to turn on the phone case body in the Items Manager. As we pull the arrow through the body, you'll see this automatically cuts out the shape of our sketch profile. This workflow makes it easy to cut out any shape from existing 3D bodies. I'll also offset this face 2.5 millimeters, ensuring there's plenty of room for the charging cable. Finally, I'll round over the edge with the fillet tool. Repeat this process for any remaining buttons. Once complete, you're all set and ready to 3D print your phone case. For best results, use flexible TPU filament. Keep in mind TPU is harder to print compared to PLA or ABS, so be sure to read the recommended print temperatures and do a small test print for first-time use. I've also linked to some recommended filament in the video description. Use Command plus Shift plus E, select 3D print, and select your desired mesh type. I recommend using 3MF as it includes units of measurement and manifold surfaces, in addition to other benefits that STL files do not include. Define the name of your model and save it to your local computer, ready to be imported to your slicing software. Last but not least, don't forget to rename your file from the Designs tab. Be sure to subscribe for more free Shapr3D lessons and check out productdesignonline.com for more resources. Then, click on this YouTube playlist to view the rest of the 10 days.